In this video, we're going to look at an exam question on variable acceleration, which is converting between displacement, velocity, and acceleration by using either integration or differentiation. Sorry, I realized I just made a mistake here. You should say differentiate. And what this is, by the way, is a template that I like to tell my students on how to remember this content. I used to write it myself when I was doing A-level maths on the corner of the page. But essentially, whenever you go to the right, you differentiate. For example, you differentiate velocity to get to acceleration, whereas whenever you go to the left, you integrate. For example, to go from acceleration to velocity, you'd have to integrate acceleration to get to velocity. In this case, we're given the displacement equation, and you want to find the times when the particle p is instantaneously at rest. So what does that mean? Well, if a particle is going upwards and it's going downwards, its velocity, if you take it as positive when it's going upwards, its velocity would be negative going downwards because velocity is dependent on direction. If we think about it logically, if we're going from a positive to a negative number, we have to cross zero at some point. And we do. It's at the top of the motion. Where we cross zero is where the particle is instantaneously at rest. So what we can do is find an equation for the velocity and make it equal to zero. Solving that equation will give you the times when the particle is instantaneously at rest. Okay, so now that we've established that, how do we get to the velocity from the displacement equation? Well, to go from displacement to velocity, we'd have to differentiate displacement. Writing that out, that means that velocity is a differential of the displacement with respect to time. In this case, 2t cubed differentiates to 6t squared, minus 18t squared differentiates to minus 36t, and plus 48t just differentiates to 48. We set that equal to 0, and then we can solve it by dividing through by 6. Now, if you were factorizing this, you wouldn't divide it by 6, but because we're solving, we're able to do that because it's going to help us get to the solution even quicker. Sorry, I'm realizing I'm talking too quickly. But once you reach this stage here, you can actually factorize. So it's t minus 4, t minus 2, all equals 0. And then you can just solve to get t equals 4 and t equals 2 are the two times when particle p is instantaneously at rest. Hopefully that made sense. And yeah, be sure to like if the video did help and subscribe. I'd appreciate it a lot.